10th Science Chapter 9 Board Question Set 1 1 mark. First, why do we see our image in a shining spoon? The shining surface of spoon behaves like a curved mirror, hence we can see our image in it. This means कि जो चम्मच का बाहरी और अंदरी एरिया होता है वो कॉनकेव और कॉन्वेक्स मिरर की तरह बिहेव करता है. Next, define real image of an object. Answer. Real image of an object is that where light ray from the object after refraction from mirror, lens, prism, etc. actually converge. This also means कि real image के वो होती है जहाँ पे light ray after reflection मिलती है. Next, what do you mean by the pole of spherical mirror? The center point of reflecting surface of the spherical mirror is called its pole. What is the center of curvature of spherical mirror? The center of curvature of a spherical mirror is the center of sphere from which the mirror forms a part. A ray of light moving along the principal axis is falling on a concave mirror. In which direction it is reflected? The ray of light reflected back along the principal axis of mirror because here angle R equals to angle I. Law of reflection is used here. Next, an object is placed in front of a concave mirror. Between the pole and the focus of the mirror, what is it? The nature of the image formed by the mirror. So the answer is virtual erect magnified image formed behind the mirror. Next, at what position the object be placed in front of a concave mirror to form the real image of same size? So the correct option is at center of curvature or at f2 in lens. What is the minimum distance between an object and its real image in case of a concave mirror? So the correct option is 0. When a mirror is held closer to the face of a person, a diminished and erect image of the face is seen. What type of mirror it is? So it is a concave mirror. Next, if the image formed by the spherical mirror for all position of the object placed in front of it is always erect and diminished, what type of mirror is it? The mirror is convex mirror. Name the mirror that is usually used by a dentist in examining teeth. So the dentist use concave mirror to see large image of the teeth. Next, what do you mean by the principal focus of a concave mirror? Principal focus of a concave mirror is a point between the center of curvature and pole which lies on principal axis, where light ray coming parallel to the principal axis of mirror converge after reflection. Next, what is the SI unit of refractive index? So, refractive index is an unitless quantity. Next, state the mirror formula of spherical mirror. As per mirror formula, 1 upon V plus 1 upon U equals to 1 upon F, where U is distance of the object from mirror, V is distance from image from the mirror, and F is the focal length of the given mirror. Next, 2 marks questions. The radius of the curvature of a spherical mirror is 20 centimeter. What is its focal length? So we have given the radius of curvature of a spherical mirror is 20 centimeter. So we know that radius equals to focal length is equals to r by 2, which means कि focal length is half of radius. So focal length of the mirror is 10 centimeter. Next, name the mirror that can give an erect and enlarged image of an object. So here it is asked erect and enlarge image of an object, so it can be only formed by a concave mirror. At the case when the image is placed between pole and focus. Next, why do we prefer a concave mirror as a rear view mirror in vehicle? We prefer a concave mirror as a rear view mirror in vehicle because concave mirror gives an erect and diminished image. As a result, convex mirror helps the driver to get a wider view of the field. A ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal, away from the normal? Here. So the light ray enters from a rarer medium to denser medium. So the ray will bend towards the normal. It is due to, as compared, the water is opacally denser medium. That's why. Light enters from air to glass having refractive index 1.50. What is the speed of light in the glass? The speed of light in vacuum is 3 into 10 power 8 meter per second. So we have given speed of light in vacuum, which is equals to 3 into 10 power 8 meter per second, and refractive index of glass equals to 1.50. From the relation of reflective index equals to C upon V, which means speed of light of vacuum upon speed of light in glass, we will get the speed of light in glass Vg equals to C upon Ng, where N is the refractive index, and which is equals to 3 into 10 power 8 upon 1.5. So the answer is 2 into 10 power 8. Next, the refractive index of diamond is 2.42. What is the meaning of the statement? When we say that refractive index of diamond is 2.42, it means that the speed of light in diamond equals to uh, speed of light in vacuum upon 2.42. Define one diopter of power of lens. One diopter of power of lens having focal length of 1 meter. Next, a concave lens forms a real and inverted image of a needle at a distance of 50 centimeters from it. Where is the needle placed in front of the convex lens if the image is equal to the size of object? Also find the power of lens. As real and inverted image of a needle is formed by a convex lens at a distance of 50 centimeters from it, hence the image of the image distance from mirror, which is V, equals to 50 centimeter, as the size of image is always equals to size of object. So h1 equals to h dot but h1 upon h equals to v upon u, which implies u equals to vh upon h1. So here putting the value, we get 50 into h equals upon h equals to 50 centimeter. So the needle is placed 50 centimeter in front of convex lens as per sign convention. U equals to 50 centimeter. Now 1 upon v minus 1 upon u equals to 1 upon f, which is lens formula. So 1 upon f equals to 1 upon 50 minus 1 upon minus 50, we get 1 upon 25. So power of lens equals to p upon 1, p equals to 1 by focal length. So power of lens equals to 0.5 d. Next, what type of lens would you prefer to use while reading small letter found in dictionary? So a convex lens of 5 centimeter is preferred for reading small letter found in dictionary. Next, set 6, 3 marks. We wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror? What is The nature of the image. Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. So the question is, we have to obtain a erect, virtual and erect image using a concave mirror within the focal length of 15 centimeter. So from this we get that the object should be placed under the 15 centimeter. What should be the range of distance of the object from the mirror? Yeah. What is the nature of the image? So the image will be virtual, erect, and larger than the object. So draw a ray diagram to show the image formation in this case. Given that the focal length of concave mirror is 15 centimeter. To form an erect image, object must be placed in front of concave mirror between its pore and principal focus. Hence, the object should be placed in front of given concave mirror at a distance less than 15 centimeter. The image form AB is virtual and erect. The size of image is larger than the object. Next, one half of concave lens is covered with a black paper with this lens produced a complete image of the object. Verify your answer experimentally. Explain your observation. So, when one half of a convex lens is covered with the black paper, so the lens produces a complete image of the object. To prove it, we will perform an experiment. So the experiment goes, take a convex lens and cover half part of it by using a black paper. Place it vertically in a stand. On one side of it, place a burning candle, and opposite side of the lens fixed a white screen. Which means we have to take a concave lens, covered it with any paper or majorly black paper, place it on a table, and opposite to it we will take a burning candle. We will place it and adjust its focal length until we get a clear image, and the image will be formed on the sheet of paper which is opposite to the concave mirror. So from this we observe that the image is a complete image of the object. From the experimental observation we find that image formation does not depend upon the size of the lens. A smaller lens can also form complete image of an object placed in front of it. But the brightness of the image decreases when some part of lens is blocked. It is because now lesser number of rays pass through the lens. Next, the magnification produced by a plane mirror is +1. What does this mean? So this actually means we know that magnification produced by a mirror is given by m equals to h1 upon h2 equals to minus v upon u. So here it is given +1 equals to h plus 1 upon h equals to minus v upon u. This implies h1 is equals to h, and image of distance of image from mirror is equals to distance of object from mirror. Since v and u are equal, the size of image is exactly equal to the size of object placed in front of it. Next, find the focal length of a lens of power -2 dot d. What type of lens is this? Given that power of lens p equals to -2.0 d, where d is diopter, as par p equals to 1 by focal length. Hence, focal length of lens equals to f equals to 1 by p, which is equal 1 upon -2 point d equals to 0.5 centimeter. The negative sign of focal length means that the lens is a concave lens. Next, a doctor has prescribed a corrective lens of power 1.5 d. Find the focal length of the lens. Is the Is the prescribed length diverging or converging? So given the power of the prescribed lens is 1.5t, and we know that power equals to 1 by focal length. So focal length of lens is 1 by p, which is equals to 0.67 meter. As the power of lens is positive, the lens is converging, which is concave mirror. How can you identify the three types of mirror without touching them? What do you mean by focal length of a spherical mirror? Okay, so A. Standing in front of a mirror, stand in front of a mirror near it and look to your image. If the image is erect and the same and of same size as you, the image does not change even if you move forward or backward. The mirror is plane mirror. Next case, if the image is erect, diminished, on the mirror is a concave convex mirror. If the image is erect, magnified and becomes inverted if one moves away from the mirror is a concave mirror. So second part, what do you mean by focal length of a spherical mirror? So focal length of a spherical mirror is the distance between the focus and the pole of the mirror. Thus, focal length equals to PF, which is pole and focus. Draw the ray diagram and also state the position, that relative size and the nature of image formed by a concave mirror when the object is placed at center of curvature of the mirror. So let an object AB be placed normally to the principal axis, a concave mirror at its center of curvature C. When we draw a ray diagram to locate the image form, we find that the image A1 B1 is formed at center of curvature itself. The image is real inverted. Size of the image is equals to the size of object. It means that the magnification of the image is -1. So if we will place an object at the center of curvature, so the image will be also formed at center of curvature but inverted, and the image will be the same size as the object real. Next, state two position in which a concave mirror produces a magnification of a given image of the object. List two difference between the two images. Two position is when a concave mirror produces a magnified image are A. When the object is placed between focus and center of curvature. For this position, the image is real, inverted, magnified, and the image is formed behind the center of curvature of the mirror. Next, when an object is placed between pole and focus of the mirror, for this position the image is virtual, erect and magnified, and the image is formed behind the mirror. Next, to construct a ray diagram, we use two rays of light which are so chosen that it is easy to determine their direction after reflection from the mirror. Choose these two rays and state the path of them after reflection from a concave mirror. Use these two rays to find the nature and the position of the image of the object placed at a distance of 15 cm from a concave mirror of focal length 10 cm. So, the position of the image formed by a spherical mirror can be found by considering following two rays. A. The ray incident parallel to the principal axis after reflection passed through a principal focus of the concave mirror. Next, a ray passing through the center of curvature in a concave mirror after reflection retraces its path. The image formed is shown in the adjacent figure. Here, for every 5 centimeter distance, we have 1 centimeter in the ray. Here AB is the object and A1 B1 is the real and inverted image formed on the basis of the observed mentioned two rays. Actual measurement shows that the image is formed 30 centimeter in front of the concave mirror, that is V equals to 30. Next, If the image formed by a mirror for all position of the object placed in front of it is always erect and diminished, what type of mirror it is? Where and why do we generally use this type of mirror? So the answer is convex mirror, which is usually used in rear view of cars. It it is always because it always give a wider view for the rider and driver. A student holding a mirror in his hand directed the reflecting surface of the mirror towards the sun. He then directed the reflected light on the sheet of paper held close to mirror. What is the distance to, to burn the paper? Which type of mirror does he use? See, will he able to determine the approximate value of focal length of the mirror from this activity? The student should adjust the distance between the mirror and the paper so that the solar rays are sharply focused on the paper. Option B. The mirror is a concave mirror. And C. The student can find the image approximate focal length by measuring the distance between the paper and the mirror. Next, state the law of reflection of light. Explain the term absolute refractive index of a medium and expression to relate it with the speed of light in vacuum. Two basic laws of refraction of light are the incident ray, the refracted ray, and the normal to the separating surface of point of incidence or lies in the same plane. Next, the ratio of sine of the angle incident to the ratio of sine of angle refracted is a constant. It is known as Snell's law. Thus, according to this Snell's law, sin I upon sin R equals to constant for a given pair of media. Generally, the constant is also known as absolute refractive index of a given medium. Thus, absolute refractive index of a medium is defining as the ratio of sin of angle of incidence of a ray light in air to the sin of angle of diffraction of a ray of light in a given medium. Absolute refractive index of a medium is a unitless quantity and its value is 1 or 2. Its value is 1 or greater than 1 in terms of speed of light. The absolute refractive index of a medium is defined as absolute refractive index of a medium n equals to speed of light in vacuum upon speed of light in given medium. Next, a convex lens forms the real and inverted image of a needle at the distance of 50 centimeter from it. Where this question is repeated. Sorry. An object of size 7.0 centimeter is placed at 20 centimeter in front of a concave mirror of focal length 18 centimeter. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? Find the size of the nature of the image. So here U is given minus 27 centimeter, F is given minus 18 centimeter. So H equals to 7.0 centimeter from mirror formula. 1 upon V plus 1 upon U equals to 1 upon F. So applying the value we get that V equals to minus 54 centimeter. So the screen should be placed within the distance of 54 centimeter from the mirror in front of it. Size of image is minus 14 centimeter, thus the image of 14 centimeter length and is an inverted image. Find the focal length of a lens power minus 2D. So this question is also repeated. A doctor has prescribed a corrective lens of power 1.5D. Find focal length of the lens in the prescribed lens diverging or converging. So given that the power of the prescribed lens P equals to 1.5t and P equals to 1 upon F. So focal length of the lens P equals to 1 by P equals to 1 upon 1.5t equals to 0.6 centimeter 67 meter. Since the power of lens is in positive, so the mirror used here is converging mirror, that is convex lens. An object 4 centimeter in height is placed at a distance of 15 centimeter in front of a concave mirror of focal length 10 centimeter. At what distance from the mirror should a screen be placed to obtain a sharp image of the object? Calculate the height of the image. Here, distance of object U equals to minus 50 centimeter and H equals to plus centimeter, 4 centimeter. So F equals to minus 10 centimeter. As per the mirror formula, applying, we will get the value of V is minus 30 centimeter, and we know that M equals to H1 upon H equals to minus V by U. Putting the value, we get the magnification is minus 8 centimeter. This image is an inverted image of height 8 centimeter. Next, a convex mirror used for rear view of an automobile has radius curvature of 3 centimeter. If a bus is located at 5 centimeter from the mirror, find the position, nature and the size of the image. Here R equals to 3 meter and U equals to minus 5 meter. By mirror formula, we get that V equals to 15 by 13 meter and magnification is 1 by 16 meter. So the image is virtual erect diminished form behind the mirror. An object of 20 centimeter height is placed 20 centimeter in front of a concave mirror of focal length 10.0 centimeter. Find the distance from the mirror at which a screen should be placed in order to obtain a sharp image. What will be the size and the nature of the image formed? Here H equals to 2 centimeter, U equals to minus 20 centimeter, F equals to minus 10 centimeter. By mirror formula, we get the value of V, that is minus 20 centimeter. Again, H1 H dash upon H equals to minus V upon U, H dash equals to minus V upon U, and H equals to 20 upon 20 into 2.0. So the answer is 2.0 centimeter. Hence an image is real inverted image. Next, light enters from air into water having a refractive index of 1.33 or 4 by 3. Calculate the speed of light in water. The speed of light in air is 3 into 10 ki power 8. The speed of light in air equals to 3 into 10 power 8 meter second, and refractive index of water is 1.33. So speed of light in water equals to C upon NV, that is refractive index into water equals to 3.6 into 10 power 8 meter per second divided by 1.33. So we'll get the answer 2.25. So coming to the 5-mark questions. List the sign convention for refraction of light by spherical mirror. Draw a diagram and apply these conventions in the determination of focal length of a spherical mirror, which forms a 3-time magnified real image of an object placed 16 centimeter on from of it. As per question and using the sign convention followed, U equals to minus 16 centimeter, magnification equals to minus 3, because image is real, and M equals to minus V upon U, which is minus 3V, and 3 into minus 16 equals to minus 48. Next, by applying mirror formula, we get that the focal length is minus 12 centimeter. The negative sign shows that the mirror is a concave mirror. Next, by the list the new criterion sign convention for reflecting of light. By spherical mirror, draw and apply these convention of calculating and nature of a spherical mirror, which forms a 1 3 time magnified virtual image of an object placed 18 centimeter in front of it. As per the question, u equals to minus 18 centimeter and m equals to 1 by 3. So m equals to minus v by u equals to 1 plus 1 by 3. V equals to minus u by 3 and the value of v is 6 centimeter. So 1 by f equals to 1 by v plus 1 by u equals to 1 upon 6 plus 1 upon minus 18 equals to 1 by 9, which implies that focal length is of 9 centimeter. The minus sign represents that the positive sign represents that the mirror is a convex mirror. A student want to project the image of candle flame on the wall of school laboratory by using a lens. Which type of lens should be used and why? At which distance in term of focal length the lens should has placed the candle flame so as to get a magnified and a diminished image respectively on the wall. So a student should use a convex lens because only a convex lens can form real image of the candle flame which can be obtained on wall of school laboratory. Second, the candle should be placed at a distance d where f is smaller than d and 2f is greater than d. Obtain a magnified image on the wall. Second, the candle should be at a distance d is greater than 2f to obtain a diminished image of the candle on the neck. A convex lens can form a magnified erect as well as magnified inverted image of an object placed in front of it, starting the position of the object with respect to the lens in each case. An object of height 4 cm is placed at a distance of 20 cm from a concave lens of focal length 10 cm. Use lens formula to determine the position of the image form. A convex lens can form a magnified real and inverted image of an object placed in front of it when object is situated somewhere between f1 and f2. On the other hand, a convex lens can form a magnified and erect image of an object when the object is situated between optical center O and focal length f. B. As per the question, u equals to minus 20 centimeter, h equals to 4 centimeter, and f equals to minus 10 centimeter. So lens formula is 1 by f equals to 1 by v minus 1 by u. So 1 by v equals to 1 by u plus 1 by f. So putting the value we get that v equals to minus 6.67 centimeter. Next, list 4 characteristics of the image formed by the convex lens. When an object is placed between its optical center and principal focus. B. The size of image of an object by a concave lens of focal length 20 cm observed to be reduced to 1/3 of its size. Find the distance of object from the lens. A. When the object is placed between the optical center and the principal focus of a convex lens, the image formed is virtual, erect, enlarged. Moreover, the image is formed on the same side of the lens behind the object. B. Hence, magnification of given concave lens M equals to plus 1 upon 3 and focal length of lens f equals to minus 20 centimeter. As per the relation m equals to v upon u uh, of a lens, we get 1 by 3 equals to v upon u, where v equals to u by 3. Therefore, as per sign convention followed, both u and v are negative. Using lens formula, minus 1 by v. If we have 1 equals to minus u by 3 and 1 equals to minus 3, so we will get the value of u 40 centimeter. So the object is placed at the distance of 40 centimeter from the lens. तो ये थे कुछ important question फिजिक्स चैप्टर 1 के according to the marks wise.